All right, so I'm just gonna do it on this paper. So what is the first thing we always do when we get our paper? We write
Put our name on it.
That's right. Today is 6/15/26. And then here there's a spot for what work we're doing. So that would be whether like multiplication, division, fractions, decimals. And then the card is where I'm gonna write this card number. That way whenever I'm checking you, I can see which one it was. So this is multiplication. I like to use abbreviations. So I'm just gonna write mult because multiplication is really long. And then the card is M3. All right. So let's start by reading this concept. So it says there are many ways to read a number sentence. In this example, and we see it says 42 equals 6 times 7. It can be read 42 equals 6 times 7. There's the first 6, 7 reference here. 42 is 6 times greater than 7, or 42 is 7 times greater than 6. So right now it gave us 4 different equations, and we're supposed to write the following number sentences in the 3 ways using numbers and words. So we're gonna do these right here. So I'm gonna write a number 1 right here so that I can see it, and I know which one it is when I go to check. So the first problem is 56 equals 7 times 8. So that's using numbers, but now we have to do these 3 ways. So, Holly, the example was 42 equals 6 times 7. What would it be for this problem if I was to do it the same way? What would that be in words? So 56 equals 7 times 8, right? So I'm gonna go ahead and write that down, and then I'll have like 3 kids with me, and I'll just we'll go through it and do it together. So let's see, and oh, they wrote the number, thank goodness. I don't have to write 56 down because that's really a lot of letters. Equals 7 times 8. Oh, and I just wrote the number there. All right, so the next one, they say 42 is 6 times greater than 7. So what would it be for this?
56 is 8 times greater
than 7. They said 7 times greater than 8, but you're right. Either way is the same. It doesn't matter the order of the 7 and the 8. So we can write it that way. And so anyway, this is just
commutative property. Yeah, baby.
and you can see there probably isn't enough room on this little section for this, but we just make do and we keep going. But anyway, and sometimes like 4 is kind of a lot if they're writing these whole sentences for all 4. So as you go through time with your card, you might realize I'm going to tell them odd or even. For these, for these, I would probably write it on there so that, like, if I find one is unreasonable, I'll be like, all right, I'm not going to get anyone to be successful at this, and we have other work to do besides this card today. So we're going to do half of them. All right. So we go through all of that, and then we're going to do the checkerboard part. And it says, complete each multiplication problem by recording the partial products. Add the partial products to calculate the total product. So, who can tell me, what are the parts of a multiplication problem?
Factors.
Okay, so we have like a factor times a factor
Equals a product.
equals a product. And then they have another set of names too, so it's kind of cool. We get to learn 2 different sets of names. We have the multiplicand times the multiplier equals the product. And so we'll record that down. Everyone write that in your notebook so that we just kind of review those things over and over and over again. Anytime I give a lesson on a new operation, I review the parts of the problem. So that's just part of what we do. All right, so in this, when we record it on here, I want to write 1 number per paper, per square on our paper. That's going to help us keep everything lined up. So our first problem is 1,500 524 times 34. And when I write that multiplier, I line up the smallest place values. So in multiplication, in addition, we always line up like all the units together, but in multiplication, we just put the smallest place values lined up. And that's not important now, but it will be later when we get to decimals. All right, so the first thing we do is we're gonna build the problem using the number tiles. So the multiplicand goes across the bottom and the multiplier is vertical. The multiplicand is in white tiles, the multiplier uses gray tiles. So we have 1,520. Oh, I did that wrong. My 5 is supposed to be red. 524 times 34. Let's see. 3 tens and 4 units. All right. So the first thing we're going to do is we're going to multiply each place value. So we have 4 units times 4 units is
16 units.
16 units. So we can only have one digit in the units place though, right? So we're going to carry the tens place over here. I put the one that I'm recording vertically, and the one I carry I put horizontal. That helps me keep track of which place value I'm on. So now we're going to take 4 units times 2 tens. 4 times 2 is 8. And units times tens is 10. So in the tens place, we're going to put an 8. All right. 4 units times 5 hundredths is?
Got 20 hundredths.
20 hundredths. So I don't have a 0, so I'm just not going to put anything there, but I'm going to carry the 2. And then we have 4 units times 1,000 is?
4,000.
4,000. All right, so that's our first step. And let's go ahead and we're going to make some exchanges here so we can record the product of our units place times our multiplicand. So we have 6. There's only one bead there, so we're good. 8 plus 1 is?
9.
9. And then nothing here. 4 plus 2 is?
6.
There we go. And then we can record this partial product down. So in the units place, we're going to write 6. In the tens place, 9. In the hundreds place, 0. In the thousands place, 6. But we're not done yet, because we still have to multiply the tens place. Sometimes I flip this over, it tells me that I'm done with that place value. So now we have 3 tens times 4 units. 3 times 4 is?
12.
12. But this blue represents what?
10.
The tens place, right?
Oh, yeah.
So when we're multiplying tens times units, our answer is in the tens place. 3 tens times 2 tens is?
6
3
tens.
times 2 is 6. 6 tens. We're going to write that. 3 tens times 5 tens. Hundreds is
15 hundredths.
hundreds. Write the 5. Carry the 1. 3 tens times 1,000 is?
3,000.
3 10,000s.
Oh, 10,000.
So now we're gonna make our exchanges, right? We only have one bead here. 6 plus 1 is?
7.
Good, right? 5, and then 3 plus 1 is?
4.
4. And now let's record that partial product. But before we write anything down, What do we notice about the color of this? We already talked about that. It's blue,
Blue.
and that means that this 2 is in the tens place. So what I like to do is I write a 0 in the units place. Sometimes I make it dash, sometimes I don't. It depends on my mood for the day. We call this the red 0. We'll discover why we call that the red 0 a little bit later. And in the tens place, we're going to write 2. In the hundreds place, we're going to write 7. In the thousands place, we're going to write 5. And in the 10,000s place, we will write 4. So we have these 2 partial products, and we're going to add them together. We'll do it with the materials first. So our tens, we're going to slide down because our tens place is going to combine with our tens place, our hundreds with our hundreds. We call this the, I don't know, I call it the slide. Sometimes we call it the magic slide, but that's more with the numeral cards. So, and now we're going to make our exchanges. So we only have 1 bead here. We have 6. 9 plus 2 is 11. I'll usually put the beads in one hand, and then I'll get my 11. So if I forget, because sometimes between here and there, I forget what I'm doing. So I'm going to write the 1, carry a 1, and then I can put them away. 7 and 1 is
8.
6 and 5 is
11.
4 and 1 is
5.
And then we're going to record our answer. In the units place, we have 6 and 1, 8, 1, 5. Now, typically, whenever I'm busy working with the materials, the kids have already added it together and they've moved on. But I still demonstrate that. Maybe that's part of why they were adding diagonally whenever they were doing it on paper. Okay, so that would be like the first time we do it, right? I'm not going to let them go too long before the second time we do it. We're going to start as I like write the 6, carry the 1, or whatever it is that I'm doing. I'm going to go ahead and write the 6, carry the 1. I know that isn't actually what the answer is. Oh, it was. Yeah, it was 16. So we're going to write the 6, carry the 1. And then we kind of are doing it with the materials and the paper at the same time, because our goal is to not use the materials, right? And like I said, we might be trying to move them a little